this is amazing. This is so cool. I can't believe I'm touching a dinosaur bone. Is this real?
Yes, it is. Hi, I'm David Whitman. I'm a park ranger here. And these bones are 150 million years old.
Wow.
Want to see something really neat?
Yes.
Follow me.
Amazing. I've never seen anything like this. Did you just put these bones on the wall?
No, we didn't. Excavation started here in 1909 and ended in 1990. We're doing excavations elsewhere. But during that period of time, we uncovered over 1,000 dinosaur bones.
How did they all get here?
A lot of them died of natural causes, and some of them died when the river dried up and they didn't have enough water.
Oh, I almost forgot. My friends wanted to find out for sure if fossils are clues towards plate tectonics and earthquakes.
Oh, I can help you with that.
I have lots of questions. What was the environment like?
Well, this was the bottom of a river, and the area was flat, arid, for a lot of plants growing along the rivers, and of course that's where the dinosaurs congregated.
Another question. How warm was the climate?
It was hot year-round, and the reason for that was that this area was a lot closer to the equator 150 million years ago. So over the last 150 million years, because of plate tectonics or continental drift, this area has moved northward 400 miles.
It's hard to believe that land can actually move that far. I read in a book once that no one believed Alfred Wagner in the early 1900s when he proposed the idea known as continental drift. What is continental drift?
It was a theory that stated that the continents were once one large landmass called Pangaea. Clues indicate that in the last 200 million years, the continents have moved or drifted horizontally to their current locations. The revised theory called plate tectonics explains why continents drift. Continents are part of large plates that move across the Earth's surface and bang into one another, causing earthquakes and pushing up mountain ranges.
You mean fossil clues?
Yes, fossils can be clues to continental drift. For example, fossils of the reptile Mesosaurus have been found in South America and Africa. These reptiles live in freshwater and on land, so how could they be found on different continents unless the continents had one time been together? Well, another clue can be found in rocks.
Strange. How do you know that a rock found here is the same as another rock found in the Colorado Plateau?
Well, why don't you come with me? We'll take a walk and find out.
Great.
Well, Jacob, this is the Green River.
Wow. I know I'd never seen anything like this before.
As you can see, there's lots of different kinds of rocks here. Rocks can be clues of continental drift, but that's not the case here.
They all look the same to me. How can you tell the difference between rock structures?
Well, it's like a detective story. If we look over at this sandstone over here, it looks like 6 other types of sandstone that we have in the monument. So how do we tell the difference? We have to look at the rocks that are associated with it. If we look at the rock that's just below that sandstone, we can tell it's the Chinle Formation. Chinle looks the same all across the Colorado Plateau. So now we know the rock above it, this sandstone, is the Glen Canyon sandstone.
Do you have earthquakes here?
Here, earthquakes are caused by mountain building forces. So 65 million years ago, as these flat rocks were being pushed up into an arch, earthquakes occurred. If you've ever seen a cake in an oven, it'll rise and rise and rise, but at some point, what happens to the cake if it rises too much?
It has to sink back down eventually.
It'll collapse. Well, the same thing happens with rocks. They'll be bent, but they can only bend so far, and at some point, they'll eventually break.
And when the rocks break, is that what causes an earthquake?
That's correct. That break is the fault line, and when the rocks move along the fault line, it creates an earthquake. Well, have I answered all your questions?
Yeah, I can't wait to go email the treehouse detectives.
Well, do you have some time to go look for some fossils?
Sure.
All right, let's go.